So we're continuing in section 8.7 in the notes, which is page 26. And now we're going to move into equations, exponential equations and logarithmic equations. To get us started, though, before we get into those equations, we need to go back to evaluating logarithms. You know that if I ask you to evaluate the logarithm log base 2 of 8, you ask yourself 2 raised to what power gives you 8, and hopefully you'd realize it's 3. But if I ask you to do something like log base 2 of 7, well, you should know that it's something less than 3, because log base 2 of 8 was 3. You should also know that it's going to be something greater than 2, because log base 2 of 4 gives you 2. But exactly what this is, well, we don't yet know how to figure that out. The first day of logarithms, we did a lot of guessing and checking to try to figure out 2 raised to what power would give us something like 7. But now we need to see how to do this for real. There's a formula called the change of base formula that will let us deal with this. If I want to do log base b of m, this is going to equal. Well, your calculator has a log base 10 button. This change of base formula will let us write any sort of logarithm in terms of a log base 10 problem. Log base b of m is the same as saying log base 10 of m divided by log base 10 of b. Or we can use our shortcut symbol for log base 10 because that's just our common logarithm, and we can say this is log m divided by log b. We're not going to worry too much about where this comes from. We're just going to see how to use this, because this is going to let us evaluate those logarithms that we can't just figure out by knowing things about their powers. For the first example, I want to look at log base 2 of 7. 2 to what power gives us 7? Well, I can use my new change of base formula. I can go to the calculator and I can type in the problem log base 10 of 7 divided by log base 10 of 2. Let me show you what this is going to look like on the calculator. To evaluate these logarithms using the change of base formula on the calculator, I'm going to show you how to do it on the graphing calculator, but it's the same on any scientific calculator. I'm going to look for that log button. I'm going to push log, and I'm going to say 7. Make sure you close the parentheses. This is very important. Then I'm going to divide this by log 2. I'm going to push enter, and it's giving me about 2.807. What this means is if you do the problem 2 raised to the 2.807, you should get 7 out of that. Well, actually, I didn't, because I just rounded to 3 places there. If I did 2 raised to the much longer version, 2.807354922, it's going to be really close to 7. And actually, it rounded it to 7 over there. So back in our notes, in letter B, we want to figure out log base 3 of 76. I'm going to use that change of base formula. I'm going to go to the calculator, and I'm going to type in log 76 divided by log 3. Go to your calculator, type that in, see what you get, and let's round our answers to 3 decimal places. Here I'm getting about 3.942, which means if you did the problem 3 raised to the 3.942, you'd get something pretty close to 76. You go try C and D right now on your own. Letter C, I'm getting 0.631, which means if you do 9 raised to the 0.631, you're going to get pretty close to 4. That seems a little strange, but I know if I did 9 to the first, I'd get 9, so I know I need something smaller than 1 to give me a number smaller than 9. Final one, if you do log 1 divided by log 5, you get 0. And actually, this is a problem we could have done without using the calculator and the change of base formula, because this is just asking us 5 raised to what power gives us 1? Well, 0. It is good, though, to see that the change of base formula gives us the same thing that it would if we were just thinking about the powers, if it was a nice number. So this is how we can evaluate any sort of logarithm using the calculator. Before, we could only deal with logs with base 10 or logs with base e, those natural logs. Now we can use this change of base formula for any sort of logarithm. We're going to now move into our 2 different types of equations. Exponential equations are the first type we're going to deal with. For example, 2 raised to the x equals 153. The first thing we're going to do is we're going to get the exponential piece by itself. Get the exponential piece by itself. In this particular problem, there's nothing that I have to do, but if I had like a plus 3 at the end or a times 4 or something, I'd have to get rid of those numbers, and I'll show you an example of those in just a moment. Step number 2, and this is the really important step. Before we get to step number 2, this equation is asking us 2 raised to what power gives us 153. Well, hopefully you're thinking that that's the same thing that our logarithms are designed to answer. Logarithms answer the question, what's the power? What I'm going to do is go back to what we did on our first day of logarithms, and I'm going to change the form. I'm going to rewrite this exponential problem in logarithmic form. Before I do that, just to remind you, remember if we have 2 to the third equals 8, we could write the same problem in log form as log base 2 of 8 equals 3. I also showed you Mrs. Eburn's trick. Log base 2 of 8 equals 3 is how you would convert that. Log base 2 of 8 equals 3. Step number 2 is we are going to rewrite our problem in log form. I have the problem 2 raised to the x equals 153. In log form, this becomes log base 2 of 153 equals x. Log base 2 of 153 equals x. So now all I have to do is figure out this logarithm, and I'll know what x is. Well, we can evaluate that logarithm using our new change of base formula. Step number 3, we are going to evaluate the log using our change of base formula. The thing that we just talked about on the top of the page. Change of base formula. So to figure this thing out, you're going to go to the calculator and you're going to type in log base 10 of 153 divided by log base 10 of 2. And I don't actually need to see this step written out. This is one of the few things that I'm okay with you skipping. If you just go to the calculator and give me a decimal, that's going to be fine. You're going to type in log 153. Make sure you close the parentheses. Divided by log 2, and you should get 7.257 is approximately what x is. Unless I say otherwise, let's stick to rounding these to 3 decimal places. There is one more step, but it doesn't really matter in this particular problem. If this wasn't x, but something like x plus 2 or 2x minus 3, our final step would be just to solve what's left. But what I just figured out is if I do 2 raised to the 7.257, I'm going to get pretty close to 153. What I hope you're realizing is this is the exact same idea that we were doing on the top of the page, just kind of written as an equation rather than just a straight logarithm. Let's take a look at the examples on the next page. There are 3 examples on the top of the page. Down. 3 raised to the 5x equals 19. Actually, let me zoom in so you see this a little bit clearer. The first thing I'm going to go do is I'm going to go rewrite this problem in log form. I'm going to say log base 3 of 19 equals 5x. Log base 3 of 19 equals 5x. Go to your calculator, use the change of base formula, and let's figure out log base 3 of 19. Hopefully that's giving you about 2.680. By the way, I'm going to write 2.680, but I'm going to leave the much longer version still stored on my calculator to make sure I'm as accurate as possible moving forward. Well then, I'm going to divide both sides by 5. Make sure you're showing all your algebra. Show me you're dividing both sides by 5. Again, I'm not going to do 2.680 divided by 5. Instead, I'm going to take the much longer thing still on my calculator, and I'm just going to push the divide by 5 button. I'm going to get 0.536 for my answer over here. In the next problem, I already have the exponential piece by itself, so I'm going to go and convert it to log form. I'm going to say log base 10 of 21 equals 2x minus 7. Log base 10 of 21 equals 2x minus 7. You can go use your change of base formula, but actually, since our base is 10 and our calculator does base 10 logarithms, we don't even need that change of base formula. You could just type in log 21 and be set. If that's confusing to you, whatever, just go to the calculator, do log 21 divided by log 10. You'll still get the same answer. So go evaluate that log. I'm getting about 1.322. And again, I'm going to leave the much longer version still left on my calculator. That's going to equal 2x minus 7. Now we just have to go through some basic algebra to solve for x. I'm going to add 7 to both sides. I'm going to get 8.322 is approximately equal to 2x. I'm going to go and divide both sides by 2. Go to the calculator to do this, and you should get about 4.161 for what x equals. In letter C, I can't go into log form right away. I first need to get this exponential piece by itself. Well, that's pretty easy. All we're going to do is subtract 9 from both sides. Minus 9, you've got 3 raised to the 2x minus 8 equals 222. You go take a moment and see if you can finish off this problem. So take a look at my work and see if you're able to get 6.4, whoops, it's off the screen, 6.459 for your answer over there. To solve an exponential equation, all we need to do is rewrite that exponential equation in log form. We'll then figure out the log, most of the time using our change of base formula, and then we'll go use some simple algebra to finish this thing off. We're also going to look at logarithmic equations, equations that already have a log in them. For example, log base 3 of x equals 4. Our process. Step number 1 is not going to matter in this case, but will in some other problems. If you look at the bottom of the page, in letters C and D on the bottom of your page, you have a couple logarithms in there, as opposed to A and B and the example in the box. Our first step is going to be to turn multiple logarithms into a single logarithm by using the properties, by using what you watched about in section 8.6. Step number 1, we are going to turn multiple logs into a single log by using the properties. It doesn't matter in this particular example, but we'll see this in some later examples. Step number 2. When I had an exponential equation, like on the top of the page, my trick was to rewrite that problem in log form. Well, if I have a logarithmic equation, my trick is going to be to rewrite it in exponential form. Step number 2 is I'm going to go and rewrite this in exponential form. Log base 3 of x equals 4. Well, I can rewrite this as 3 raised to the 4th equals x. 3 raised to the 4th equals x. Well, step number 3. Just going to finish that off and evaluate and do any solving if I needed to. 3 to the 4th, that's nothing fancy. That's just 3 times 3 times 3 times 3. That's just 81. Your answer is x equals 81. If we were to check this, log base 3 of 81, yep, that is 4. If we have an exponential equation, we're going to rewrite it in log form. But if we have a logarithmic equation, we're going to go and rewrite it in exponential form. Letter A. I have log base 2 of x equals 9. I'm going to go put that into exponential form, and I'm going to say 2 raised to the 9th equals x. Make sure when you're doing this in exponential form, you no longer have any logs written there. It's actually a very common mistake to say log base 2 of 9 equals x. No, that's not the case at all here. It's the problem 2 raised to the 9th power, no logarithms, equals x. Well, go to your calculator, figure out 2 raised to the 9th power. Again, we're not using logarithms here. We're truly just doing 2 raised to the 9th. And you should get 512 for your x value. X equals 512. In letter B, log base 4 of 3x minus 11 equals 2. I'm going to go and convert that to exponential form. So I'm going to say 4 raised to the 2nd power equals 3x minus 11. 4 raised to the 2nd power equals 3x minus 11. Well, 4 raised to the 2nd, that's just 16. 16 equals 3x minus 11. Take a moment and go through the easy algebra to finish that off. And that should give you x equals 9. 2 more examples, and then we'll be set. In C and D, we have multiple logarithms. Not okay. We can't deal with solving an equation if there's more than one log in there. So we're going to go and use step number 1 of the process that we haven't yet used that says to turn multiple logs into a single log by using the properties from the last section. Hopefully you remember that when we subtract logarithms, we divide the stuff inside. So I'm going to say this is log base 3 of x over 2 equals 7. I'm just going to divide x by 2 inside my log. Now I have a single logarithm. Now I can proceed the way I did in A and B. Actually, you take a moment, see if you can solve this. you should get the exponential equation 3 to the 7th equals x over 2. Well, that's 2,187 equals x over 2. Get rid of the divide by 2 by multiplying both sides by 2, and x is going to end up equaling 4,374. Last one, letter D. Because we're adding these two logs, we're not going to divide the stuff inside. Instead, we're going to multiply the stuff inside. We're going to get log base 4 of, well, let's see, 3x times 7 should give you 21x equals 5. See if you can go solve, and when you're done, I'd like you to give an exact answer. Give me a fraction, don't give me a rounded decimal for this one. (1,024 over 21). And moving forward with these, anytime that you can give an exact answer, like a fraction like that, rather than a decimal, do give me those exact answers. You can't usually do this with the exponential equations like we used on the top, like we dealt with in the top, because we had to use logarithms in that change of base formula. But usually when we have logarithmic equations, like we have in the bottom of the page, yes, we can get exact answers. So this should be it for right now. I realize there's still more in the notes. We will deal with that stuff in the next video that you're going to watch for the next class. But you should have everything that you need to be able to do the homework. And the homework is page 52, 1 through 4, all of those. That should go pretty quickly, though. And then 5 through 29, odd. Make sure that's actually on the screen. Page 52, 1 through 4, all. 5 through 29, odd. And that's it for today.